to part 2 of the OGT science review for physical science. We're also going to have some life science review, earth and space, etc. But this part is going to be basically about elements and their properties today. So here's our first question. Strips of 2 different metals are placed in a solution of acid as shown in the picture below. Now please notice though you have wire coming out of the solution and the light bulb is lit. Okay, so what indicates that ions are being formed? Remember, if there's ions in the solution, ions will conduct electricity between the plates. So we can trace a path through the solution to the other electrodes. So we do have a complete path. That's why the light is lit. And that is how we know that ions are being formed, because there's an electrical current is present between the metal strips. And so ions in a solution can conduct electricity. So that's something you'd want to remember for maybe other future questions. And some related questions then. It says solid copper wire is a good conductor because copper contains no protons. That's not true. All elements have to have protons. Electrons move easily within the wire. Protons and electrons tend to cluster at opposite ends of it. Copper contains the same number of protons and neutrons. So actually, good conductors are because electrons can move easily within the wire. So it's that movement of electrons that carries that charge, because the electrons are the charged particles. So that would be B. And check out a related question from the year before. Number 17, a student is testing the conductivity of 2 solid substances. Substance A has high conductivity and substance B has low conductivity. Based on this information, what must be true regarding these 2 substances? Electrons in substance A are able to move more easily than those in substance B. Remember, we just reminded you, electrons moving is a good conductor. A was high conductivity, so electrons in A moving more easily certainly does sound reasonable. There is more energy stored in chemical bonds. No, that's not the reason for the conductivity. The atomic nuclei in substance A have more mass than the atomic nuclei. Again, that's not related to our conductivity necessarily. Substance A contains a higher percentage of radioactive atoms than does substance B. No, you don't. It doesn't have to be radioactive to conduct electricity. So we were correct in our thinking here that A is correct. It's the electrons moving more easily that makes it a better conductor or higher conductivity. So here's a little experiment done with we have a battery, wires connecting to a motor. It goes over this hot pack, and then the wire seems to attach. It doesn't quite attach. It says it's a large view. The wire is very close, very close to the lead on that motor lead. So if that were to touch, that would make a complete path, but it's not quite touching yet. Interesting. For a science fair project, a student has built the following apparatus to demonstrate energy transformations. The battery is made from a zinc-containing paste which releases electrons and a mercury compound which accepts electrons. Because these substances are separated, electron flow occurs only when the battery is part of a complete circuit. The hot pack is a sealed plastic bag. Water and calcium chloride are stored separately inside the bag. When the tab is pulled, the calcium chloride mixes with the water and dissolves. The dissolving process is highly exothermic. Exothermic means it gives off heat. You've probably seen some of these. Many first aid offices have these hot packs where you have to squeeze the pack so that the chemicals inside mix, and then you see it getting quite warm. And by the way, calcium chloride is also known as ice melt. This can also be used as well as sodium chloride to melt the ice on your driveway and all. And so that's an exothermic reaction creating heat. So that's the point of this hot pack. Wire B is in physical contact with the outside of the hot pack. So the wire B is touching the hot pack. Wire B is very close to the motor lead but does not quite touch it. And they show you the open gap shown. It's very small though still. Before the student pulls the hot pack tab, the motor is inactive. Once the tab is pulled, the temperature of the hot pack increases and thermal energy is transferred to wire B. The wire expands, making contact with the motor lead, so that closes that gap, the expansion of the wire. The motor becomes active and the fan begins to rotate, creating a breeze. So you see the expansion of the wire because of the heat from the hot pack. So here's our questions. What changes in the hot pack over the course of the demonstration? The total mass, the number of protons, the number of atomic nuclei, or the amount of thermal energy? So I hope you would agree, since the hot pack now gets hot, they don't actually say it gets hot. They use the words highly exothermic. Exothermic means gives off heat. By the way, the opposite of exothermic is endothermic, if that were to come up on any other questions. Endothermic means heat is absorbed, so it feels cold. And I think they also have cold packs in that regard too. So this would be the amount of thermal energy. By the way, the package is closed, so nothing can escape. So nothing can get out, so these are not being changed at all. Number 21 says, the energy conducted through the circuit will cease at some time after the hot pack stops conducting electricity, chemical reaction in the hot pack ends, the blades are disconnected from the motor, mercury in the battery begins releasing electrons. Okay, so be careful. Some students are going to pick A. The hot pack is not conducting electricity at all. The hot pack is just heating the wire so that it expands in order to complete the circuit. So it's definitely not A. But at some point, if you've ever used any of these, the hot pack is not going to be able to stay hot forever. So as that pack tends to cool down, that means then the wire will begin to contract a little bit again, and then it won't touch the lead. So that is the reason the energy conducted through the circuit is going to stop or cease. They use the word cease instead of stop also to fancy it up. So it's the chemical reaction in the hot pack is going to eventually have to end. Number 22 says electrons in the wire cannot flow into the hot pack because. So the electrons are flowing along the wire. They're not going into the hot pack because only positive charges flow through wire B, because hot pack atoms have higher kinetic energies, because the plastic bag has low electrical conductivity. The hot pack does not contain any electrolyte solution. Okay, so I hope you know that plastic is a good insulator, which means it has low electrical conductivity. So the wires overtop the hot pack, so the electrons in the wire can't get through the plastic. And as a matter of fact, most wires you see around, I don't know if you shouldn't be seeing wires actually around your house, but if you're doing any electrical work at all, the wires are already encased in a plastic coating so that they don't conduct electricity between themselves when they're touching. So plastic is a good conductor. It has low electrical conductivity, so electrons cannot flow so well. One last question about our demonstration here. Assume that the electric current remains complete. Which change in the system would cause a slower rotation within the motor? So as long as the electric current is complete, what could we change to make it rotate slower? Okay. Reducing friction in the mower. Now, if you reduced friction, if the things you've studied from energy and motion, that should make a faster rotation. Decreasing the length of wire B. Now, if you decrease the length of wire B, that would cut off the circuit. So, although it said assume that the circuit remains complete. So I guess then it would be using the absolute shortest piece of possible. But if you decrease the length, that also decreases the resistance. There's less length for the electricity to go through, so that wouldn't cause a slower rotation. That could cause maybe a slight bit faster. Increasing the size of the fan blades. If you increase the size of the fan blades, that means now the electricity has to do more work to make the larger blades move. So that would probably cause a slower rotation within the motor. Reversing the direction of the current flow in the circuit would not be an effect. So it's increasing the size of the fan blades, which causes more work to be done. So that's going to slow us down a little. I think that is the end of the questions from that demonstration packet. So here we are, using the diagram. Okay, so I guess we're just using this small diagram to answer this question number 37. So it points to this as the atomic number. This is your symbol. That's your name, which is carbon. That's your average atomic mass. It says the atomic number of carbon is 6, which means that carbon atoms always have 6. Always have 6. That would be protons. Okay, the atomic number is the number of protons, because each element is distinguished by their protons. Carbon and only carbon has 6 protons. Hydrogen and only hydrogen has 1 proton, and so on. You can change the number of neutrons to get to different isotopes, which affect your mass. And your electrons, normally you have also 6 electrons. That would be, though, if the atom is neutral. Sometimes atoms gain or lose electrons, which means that they wouldn't always necessarily have the 6. So the atomic number actually is a measure of the number of protons. Okay, so that's kind of important to remember. And also, if it's neutral, protons will equal electrons if they're neutral. A teacher gives a student a non-toxic, odorless white powder to identify. So that means there's safety in that lab. It's non-toxic. Generate 4 questions, each regarding a different property of the unknown powder that could be safely tested and answered in the lab. Now notice they already told us it didn't smell and it was white. So please don't ask questions like what color it is. You're not going to get any points for that because it's already listed there. Okay, so here's some. I've got a few. You're supposed to come up with 4. I think they may have maybe 5 questions or something. So these are some of the things that you study about elements and their substances. What is the melting point of the powder? So that could tell us, that could identify a substance by its melting point. The density, what is the density of the powder? That could help identify the substance. Does the powder dissolve in water or maybe any other liquid? What color is given off in a flame test, or is the powder flammable? So the color given off in a flame test is also another indicator of what substance it might be. Does it react with any other substances? So that could also identify what it might be. Is it crystalline or not? Some of the solids are crystalline, and like salt, for example, is a crystalline solid. So I think that's 1, 2, 3, 4. That's 5 different questions that you could choose from. So there might be other questions that you could ask, but these might be the highlights. This next one is just a partial picture of the periodic table that we're going to be using for the next few questions. Again, if you notice, they borrowed this for that other question we had before. Okay, so it says use the partial periodic table to answer question 16. Would you normally expect neon to form compounds? So we're going to try to find neon on the periodic table, Ne. I know where it is, but you might have to scan quickly. And you see here's neon. And they ask us, would we expect neon to react to form other compounds? Okay, now neon is in group 8A. And these groups labeled with the A's tell you how many valence electrons are in that substance or that element. So neon has 8 valence electrons. And if you recall, 8 valence electrons is very stable. You want to have 8. If you have 8 already, then you really don't want anybody else's electrons, so you're probably not going to want to react with anyone. So we would not normally expect them to form a compound. No, neon has 8 electrons in its outermost level and is stable. So you got to remember that 8 is what is stable, and you get that number from the A numbers on here. Not just the normal numbers, because if you notice, technically this is also column 18, but it's called column 8A. This is column 17 or column 7A. So that tells you how many valence electrons are on the outside. So we don't expect neon or any of its family to do much in the way of reacting with things. Question 7. Use the partial periodic table to answer 7. In terms of electrons, describe the difference between the formation of the covalent bond in Cl2, which is 2 chlorine atoms bonded, and the ionic bond in NaCl or sodium chloride. So a covalent and an ionic respond in the space provided. In terms of electrons, we're looking for chlorine and sodium. Chlorine is in 7A, so that means chlorine has 7 valence electrons. If chlorine only had 1 more, that would make a stable 8, and chlorine would be happy, very happy. Let's find sodium. Well, we circle chlorine in 7A. Sodium is way over here in column 1A. That means sodium has 1 valence electron. If it lost its valence electron, it would go down to its next shell, which would be, guess how many? A stable 8. Okay, so sodium would like to lose an electron. That's why sodium loses an electron to chlorine in that ionic bond. Okay, so knowing that information about the electrons, here's what we have. It says Cl2, or chlorine, is a covalent bond formed by 2 chlorine atoms from group 7A sharing a pair. Because if you recall from before, covalent bonding is all about sharing pairs of electrons. And so that gives each atom a stable octet. So for example, here, this could be the 7 electrons from this chlorine atom. 1, 2, 3, 4, 5, 6, 7. Over here, we could have the 7 electrons, valence electrons from this chlorine atom. And there's 7. So, but instead, in a covalent bond, instead of turning something into an ion, we share a pair. So we're going to share this pair. So this chlorine atom thinks that pair belongs to him. This one thinks those belong to him. So they each are technically fooled into thinking they have an 8 electrons. So that's what happens for covalent bonding. And so it would be a good idea to have a demonstration of these dots. They're called the Lewis dot diagram of sharing. Okay? But however, sodium chloride is formed with an ionic bond where the sodium atom in group 1A gives up an electron. So sodium loses an electron, which makes it now positively charged, a positive 1 charge, because it's lost an electron. But chlorine now has gained an extra electron, giving it a negative 1 charge. And so then now each of these have a stable octet of electrons in their outer shells. So there's an actual giving up of an electron to form the ions when you have an ionic bond, and a sharing of the electron there to form a covalent bond. We also are able to use this if we need to answer question 31. It says, use the graphic to answer 31. And it gives you a shell model, and it mentions that the open circles are the neutrons. The filled in darker circles are the protons, and this has like the little negative on it. I don't know if that's a hint because the electrons are negatively charged or it's just a way to identify them. But they want to know which element does the shell model represent. Okay? So it's an element. It's not an ion. So that means it has all its protons, all its neutrons, all its electrons. Nothing's been shared out. So we can count, say, the electrons. 1, 2, 3, 4, 5, 6 electrons. We could count the protons as well. 1, 2, 3, 4, 5, 6. Electrons and protons should match on a neutral element. And so if it has 6 protons, which in this case also 6 electrons, it again has to be carbon, because the number of protons is the atomic number that they place on the chart there. And if you noticed anything too, just to validate some of the things we've been talking about in the past here, carbon is in group 4A, which means it has 4 electrons in its outer shell. Check it out. 1, 2, 3, 4 in the outer shell. Okay. Moving on to number 36. A metal that can be hammered out or rolled into thin shape is best described as, well, that again is just a vocabulary word. It's the vocabulary word of malleable. That's what malleable means. It means you can, if you hit it, it's not going to fall apart. It'll be dented, and eventually you can, bend it or hammer it into shape, whichever. Like you remember some of the old Westerns, they have to heat it up, of course, but they're making their horseshoes and they're trying to bend those and put whatever finishing touches they need on them. And malleable and brittle are almost like opposites. If you were to pound something that's brittle, it's going to fall. It's going to land in a bunch of small pieces. Like for example, glass. If you take a sledgehammer to some metal, you might dent it. Sledgehammer to some glass, it's going to break up into small pieces. And by the way, this is another word that you should know for chemical properties. Ductile is another description. Ductile means it can be, say, formed into long shapes. So things that can be made into wires, for example, exhibit high ductility. So most of your metals are both malleable and ductile. And it doesn't have to conduct electricity to be formed into a wire. So, but ductile just means it's able to be formed into a wire and it would not break. Can you imagine a glass wire? Okay, so some of those things would not hold up. Number 35, just quickly noticing this, these dots are what we were talking about again for that covalent bonding. It says, suppose scientists discovered 4 new elements, W, X, Y, and Z, while studying a rock and soil samples brought back from Mars. So it says suppose, so this is not really true, but which Lewis dot structure represents an element that should be placed in column 7A, or number 17 of the periodic table? Remember, 7A means it needs to have 7 electrons, and that's what these dots represent, the outer electrons. So if we count them, 1, 2, 3, 4, 5, 6, 7, so I'm saying it's W. This is Y, this has 8, so I would think Y is most likely in this column, 8A, because it's got 8. X has got 1, 2, 3, 4, 5 electrons. It should be over here in 5A. And Z's got 1, 2, 3, 4. It would be over here where we looked at carbon earlier. So column 7A, really you don't even need a picture of the periodic table. Those A numbers tell you how many electrons are out there, 7A. However, I do notice something though. You do have to make sure you can do your Roman numerals. If you don't have the chart as well, if you have the chart, you could say 1, 2, 3, 4, 5, 6, 7, if you're counting just by A's. But yeah, that's your Roman numeral 7A. Because remember, V is Roman numeral 5, V is a 5, and then 1 more is 6, 2 more, that's 7, etc. Number 42, graphite and diamond are both forms of pure carbon. Graphite is soft and gray, while diamond is hard and transparent. The physical properties of graphite and diamond differ due to. So they're pure carbon, but they're different not because of the charge of their electrons. All electrons have a negative charge. Their average kinetic energy, if you recall some of the information about solids, in solids, the particles are simply vibrating. There's not a whole lot there of actual movement. The bonds between their atoms, And number of neutrons in their nuclei, no, because they're made of the same carbon. So it would be, it would be their bonds. The bonds between their atoms. How they're bonded together. Number 17, a student is testing the conductivity of two solid substances. Oh, excuse me, I think we already read this question, did we not? I must have had it in here twice. Yes, I'm sorry that I put that question in the packet twice. But anyway, so remember, high conductivity means electrons are able to move more easily. Okay. And we're getting close to the end here. Two identical flasks containing different liquids are placed on identical balances. If you look closely, I think they are both at the same level. They have the same amount of liquid then in each one. Based only on what you can observe from the picture, it looks like they have the same amount of liquid, but notice the readings on the balances, 22.57 grams and 30.05 grams. What property differs between the two liquids? Okay, now if you recall, this type of flask, they called it a flask. You could also call it a graduated cylinder. It would be used for measuring the volume of that liquid. And the balance, measuring in grams, is measuring mass. So if you can remember, so we can't say that the volume is different because actually the volume is the same. Okay, but what we cannot look at conductivity. We don't have any lights flashing or anything, or alkalinity. Alkaline, that would mean whether it's like basic or acidic type thing. You can't tell that from looking. So it would have to be density. And we just want to remind you, you might have a question about density. Density, remember, was defined to be mass divided by volume. In case that comes up on something that you need. So this would, you could find density because you have both volume and mass. Question 44, it says the water level in a graduated cylinder, which would be a device like that. Graduated cylinders are thinner so that you can measure more accurately because the water level has to be higher for the same amount of water. Say you put the same amount of water into a graduated cylinder as you did into a big beaker. Well, the level in the water in the beaker might be here, but in the graduated cylinder, it might be up to here. So it's easier to read the different levels, how accurate it is to read them. So that's why those are used. Anyway, the water level in the graduated cylinder rises from 10 to 35 when a solid lead ball is added. What is the approximate volume of the red ball? Okay, so they're saying water, so you know that you're measuring volume. And this is volume in cubic centimeters. You could also use milliliters, but they're using cubic centimeters, which is another unit for volume. So you would just say if you go from 10 to 35, what's that change? From 10 up to 35, you would just simply subtract. So that gives you the volume of the solid ball that you put in there. And this reminds me of that little story about, who was it? Archimedes. He yelled Eureka that time when he sat in the bathtub and realized that the water level moves up when he gets in. So that was to help him with that king's crown idea. But anyway, so that's what happens. If you can, when there's something irregular and you can't measure its length, width, and height easily, you can drop it in water and see how much the water level rises. Okay, these are our last couple of questions. Gertrude cut 2 bars of different types of soap into 4 pieces each. She placed 1 piece from each bar into each of 4 beakers, and she labeled her beakers, and each beaker contains a different unknown liquid. According to the results shown above, which beaker contains the liquid that was densest? So if you recall, density deals with buoyancy as well, or floating things. Less dense items tend to float on top of more dense items. So the less dense item will float. So in this beaker, both items are floating. In this beaker, they both sank. So this liquid can't be the densest because both of them sank. This one sank in this beaker. This one is kind of suspended, so that means its density is very close to the density of the liquid. So the beaker that has the densest liquid would have to be beaker W because both items are floating in that one. So beaker W, which is answer A. So that's about floating. And number 26, again, another question on density. I tried to chunk questions that were similar together. At 25 degrees C, water has a density of 1.0 grams per milliliter. Vegetable oil has a density of 0.90 grams per milliliter. How would a substance with a density of 0.95 behave when placed in both oil and water? So we've got oil. Here's our oil with our density of 0.9. Here's our water with a density of 1.0. And we're going to put in our substance with a density of 0.95. Now notice, 0.95, and if you need to think of it in terms of money, this is like 90 cents, 95 cents. We could add another zero if we want. That's like a whole dollar. So 95 is definitely in between these. So remember, less dense items, so again, back to this problem, these are less dense on top of something that is more dense. So if you put this is more dense than this because 0.95 beats 0.9, so it should sink in here, which is the oil. But 0.95 is less dense than 1.00 of the water, so it should float in the water. So which answer says that? This says sink in both. Sink in oil, check, and float in water. Sounds good to me. Float and sink, that's backwards. Float on both, no, backwards, so it's B. So there we go. So that finishes this video on the physical science part, including the elements and their properties. We'll be doing some more on earth science and some on life science and maybe some information on the environment as well. We look forward to more videos. Please make sure you're studying for your science OGT.